Welcome back to the second half of this week's lecture. It's instrumentation and controls. So we'll be dealing with SCADA and whatnot. So you got different types. You got primary and secondary, and then you get the control elements themselves, right? Primary sensors are going to be those for your like flows, your pressures, levels, temperatures, and then secondary instruments are going to be those that display that information. So it would be like an analog signal or like a digital signal. Um, and then you get the control element, right? And that's going to be what controls the pump. That'll be like a almost like your fuses, if you will, right? That will monitor the electrical current going into like your pumps, motors, and so those are the three different categories that we'll be discussing. Primary monitoring, you've got flow sensors, right, for meters. So you got different types of meters, right? You got your pressure differential, venturi, mag, velocity, and all of these have to be equipped, like it says, with that electrical output or pulse that's proportional to the flow rate, right? So it needs to be able to measure what it is that you are pumping, um, or excuse me, whatever is flowing through that meter. You've got pressure sensors, um, and those will be installed at pressure pump stations, reservoirs, maybe just random locations throughout your distribution system, chemical injection systems, um, and then you've got the transducer that will take that pressure, kind of like that thermistor, like we discussed when we were talking about pumps and motors, and it will produce it will generate, excuse me, the current and be able to show you what that pressure is, which I think we're going to discuss here in just a sec. Primary monitoring sensor would be your level sensors, and as you can see here, they measure several different types of units or facilities that that are used in the water industry. Here we have temperature sensors, a couple different types. You got the thermocouples and the thermistors. I think we discussed all this during the pumps and motors part, so I won't go through it again. But you can see just another primary monitoring sensor. And then you have electrical sensors, like I said, these monitor the status of the equipment. So you have a runtime unit or your motor. You want to make sure that the electrical power going to those units doesn't fault. There's not an overcurrent, undercurrent, and so these are going to monitor that and give that feedback back to your SCADA system. You have different another primary monitoring sensor would be something for like your vibration, on the motor and the pump, and then your analyzers for your water quality equipment. Secondary instruments, now, like I said, these are going to display that information, right? So on your SCADA system, anytime you see that, you can think of it as a secondary instrumentation. And so that will, all those primary instrumentation sensors that we just discussed, those are getting transmitted into your SCADA system and being displayed for you. Another would be your an analog or digital signal, right? And so a lot of the equipment that we discussed in the primaries is, capable of being displayed in these two different ways. Telemetry. This is how that signal is being sent from your remote site to a common or a central location, right? So it is defined as a system that's sending data over long distances, consisting of a transmitter, transmission channel, and a receiver to monitor and control instruments remotely. Right. So, like we said, when you're talking about SCADA, it's the supervisory control and data acquisition, meaning that you can both monitor and control uh, the pumps, or you can manipulate the system remotely. To dive into it a little bit more, telemetry is how communication moves from the sensor to the indicator. Um, you will have a couple questions about this stuff on your um, quiz and your final. And so I put in red the stuff that you really want to pay attention to here. You have your remote terminal unit, and that is used to gather the information from those primary units or primary instrumentation, and then you've got your control terminal unit, and that's it says receive in formation. That should be one word, not I mean technically, that's grammatically incorrect, but you it should say information, not information in a digital signal. Okay. We have transducers, and so that those are going to take that measurement from your primary instruments, run it through a 44 to 20 milliamp signal, and that's going to convert that into a measurable readout for you, or input, and send that through the remote terminal unit. So that signal that's being transmitted from those remote locations to the central unit is going to travel along two different ways, right? You're either going to have an audio analog or some kind of a digital signal, right? And so those are the two typical ways that that is happening. So your common analogs will be a pulse duration, a variable frequency, current and voltage. Um, excuse me. Multiplexing is a a way for that information to communicate from the remote location to the central location. And really, like I said here, it's a method for sending signals from more than one sensor over the same line. So you've got the different types here. You've got tone frequency, scanning, and polling. Uh, Polling is what I'm most familiar with. That's just what our SCADA system uses. And so basically, it's just what it's happening is just constantly sending out a signal to each facility and requesting the information that it has. And so it just 20, it's just we have multiple sites and it's just constantly pinging them saying, "Hey, what new information do you have?" And so it can take, a couple minutes for that information to come in. Um, but that's the idea of how it's working. In order to control the, let's just say pump out at a site here, you've got different ways of sending that signal back and forth, right? So you have duplexing here. Um, there's different types. You got full, half, and simplex, right? So in full, you can do both send and receive at the same time. With half, the signals pass in both directions at one time. And then simplex would be, you can only go one direction at a time. So when you're sending out that signal, it can, that's how it's working. Another way, transmission channels. You can have like a privately owned cable. So, like it says here, like a wire between two buildings. That'd be like a landline. If you're old like me and used to game with your friends that way, you could lease a phone line. We've had. That's how we used to do it initially. Was we had a phone line that would connect from one point to another point, over several miles too. And then it could also be radio. There's, sending radio signals, and then a microwave system. Thinking about control systems, there's two different methodologies. You could be manual or automatic. Um, Obviously, the manual way would be you physically going out there and having to open and close valves, flip switches, whatever it may be. And that's a very inefficient way to do it. It's time consuming because it requires the operator to drive out to all these locations to make all these adjustments. And about the only time that you should be doing something like this is during like a power outage and you don't have that ability to operate your system remotely. So, like I said, very labor intensive. I can recall for many, many years as an operator where, in order to fluctuate a reservoir that was within our system, we had to drive out 20, 30 minutes to get to a valve to close the valve, and then you'd have to go back out several hours later, open the valve, and that's just how we cycled that valve until we finally got some automatic controls to be able to, operate or fluctuate the reservoir level in that reservoir. So um, that's direct manual control in a nutshell. Remote manual is what we all prefer, right? You can send a signal out to a remote site and it will complete that operation for you. And you're not having to drive to all these sites. It's very efficient. You've got a lot more information to work with too. So if you can look at several different sites as you're trying to figure out how you're trying to manipulate, let's just say a pump station or a regulating station, you can see the different levels in the reservoir. Um, and make adjustments or see pressures and make adjustments. So this is the preferred method of control system anytime you're operating a SCADA system or a distribution system, excuse me. Automatic, that would just be, programming in levels, pressures that will tell the equipment when to turn on and when to turn off. So let's say that you've got a level set point in your reservoir that says, hey, once it reaches just, for example, 5 feet, then, this regulator will open or this pump will turn on and it will fill the reservoir until it gets to 11 feet and then it will shut itself off. And so that would be an example of an automatic control, right? It operates without you actually having to send the signal to it. HOA switches, these are hand off and auto. So typically the pumps out at your pump stations, these are all going to be set in auto, unless you're doing some kind of testing or you need to evaluate the pump. Then you would place it in a hand mode, which just turns it on. Hand mode means that you're going to turn that pump on, and then obviously off is off. SCADA, like we've talked about, SCADA supervisor controlled data acquisition. That's something if you don't know by now, come talk to me. Again, this is your secondaries instrumentation, right? So we're getting the displays here, right? But you could see that you can virtually see everything that you want to see from your remote sites. You can have that brought into your SCADA system at that central unit. Um, and so uh, this is how you're able to operate that SCADA system. Now that you have an understanding of like the primary, secondary, the different ways of either manual, automatic, uh, controlling your system, you can start to get a bigger picture here and how it all kind of ties together, right? So there's that, you can send out commands to the sites to start, stop things based on, or have it automatically control itself via a level or a pressure. Um, and then, so anyway, you kind of get the idea here. This is, how SCADA systems are put together. You're talking about SCADA, there, you have a primary method of controlling and monitoring the industry, right? And when I say industry, I mean your system, right? Four components that you have to have in order for this to work, right? You have to have a remote terminal unit. You have to have some form of telemetry to be able to send that signal out to it. And then you've got a central control location. And then last here, you've got, you need to be able to review command. Command is that big part to SCADA, right? You have to be able to control it. If you can't control it, it's just a monitoring system. It's not a true SCADA system. That centralized control unit that can be at a fixed location, and then you can have a distributed computer control, meaning that you can have a laptop or some kind of an iPad, some kind, something like that to be able to do the same thing as that central control computer. Um, and so these are the components that really make up that SCADA system. Okay, so we've talked a little bit about 4 to 20 milliamp outputs in the past, right? So that primary instrumentation, it needs to go through a 4 to 20 milliamp converter in order for that to be displayed in that secondary instrumentation, right? So, but why, right? Why the 4 to 20? And that's really just because if that milliamp reading ever goes outside of those values, you can identify that there's a need for calibration, right? So if you um, have, let's say, a valve position indicator on a regulator, and you're calibrating that levels or that position indicator, and on your 4 to 20 milliamp when you're hooked up to it, right? If you get a milliamp reading of, let's say, you know, 3 or 2, right? You could tell that it's out of calibration. And so what that would mean is if you didn't calibrate that, you would see a 0 or you would see a 4, which would represent 0%. However, that regulator may not be fully closed or so anyway, and then vice versa, right? If it's up, and it's showing you 100%, but really it's not actually reaching that value. That would be another reason that you'd need to perform calibration. And so that's the methodology behind using 4 to 20 milliamp. All right, we got a problem here, right? So what percentage is equal to 16 milliamps, right? So if you want, I'm going to give you a minute if you want to hit pause and solve this, right? Um, yeah, otherwise we're going to move on. Okay, so 16 divided by 20 will give you 0.75 or 75%, right? So hopefully that's what you came up with. Pretty easy to do. But that's uh that's 4 to 20 milliamp. Okay, and then here you go. Like I said, the range is only 16, right? So just keep that in mind when you're thinking about it. Um, and It's usually measured using an odometer. Um, and if you have like controls techs and whatnot, they're all pretty familiar with this stuff. And then going back to the electrical discussion that we had, obviously this is a battery powered device, so it would be direct current, just to kind of tie those things together. Okay, couple problems. Here we go. Um, you have a reservoir that is 40 feet tall and has 32 feet of water in it. What is a milliamp reading at that level, right? So if you want to hit pause and take a stab at it, go ahead. Otherwise, we are going to move on in 3, 2, 1. So we know that we have 40 feet in that reservoir, right? And so that's going to be represented by 100% or 20 milliamps. The next thing we know is that we've got 32 feet of water in that reservoir, right? So you take 20 milliamps minus 4, you get 16 milliamps, right? So there's the 100%. And so if we take 40 divided by 16, we know that we have 2.5 feet per milliamp in there. Um, so take 32, divide that by 2.5 feet, and you're left with 12.8 milliamps, right? So that's 32 feet equals 12.8 milliamps on that 4 to 20 milliamp scale. And this one already gives it to you. Bummer. All right, well, here you go. You have a pressure gauge that reads from 0 psi to 200 psi. The pressure reading's at 120 feet, 25 psi. What should the milliamp reading at this be at this psi, right? So again, 200 equals 100% or 20 milliamps. If we subtract the 4 milliamps from there, and then take 200 divided by 16, you get 12.5, and then 125 divided by 12.5 equals 10. So you can see how that works. And with that, always remember to emphasize safety when working with electronic blah blah. Right? There's my safety disclaimer. That's it for this week's lecture. Hopefully you got something out of it. And I will see you next time. Bye.